Hello, this is the luckiest maths teacher in the world, and today I want you to be able to solve equations using flowcharts. Now, to do that, I'm going to use the machines that I showed you when we did algebra. So, let's draw a machine here. Let's say this is a +3 machine. So whatever number I put into this machine, it just adds 3 to it. So let's say I put a 6 into this machine. So out will come the number 9. If I put 15 into this machine, the machine adds 3 to it, so out comes 15 plus 3, which is 18. Now I can put any number I want into this machine, and it will just add 3 to that number. Out will pop that number plus 3. Okay? Simple as. As I said to you, mathematicians are lazy, though. I don't want to write number all the time, so I might just write n to be that number. So if I put n into the machine, out pops n plus 3. Remember, n just stands for an unknown number. Now when we're solving equations, we're thinking about what we need to put in the machine to get a certain result. So let's say I got 17 out of this machine. So what do I need to put into the machine to get 17? Okay, so basically I'm going the other way. I want to know what I needed to start with. Now I can't just add 3, because if I add 3 to 17 I get 20. Okay, that's clearly wrong. Because if I put 20 into this machine this way, out would come 23, okay? So it can't be 20. So you can probably figure this out because we did solving equations by inspection. So what would I need to put in this machine to get 17? I need 14. Because 14 plus 3 gives me 17, okay? Let's look at another example. So let's say this here is a times 4 machine. So for example, if I put 6 into this machine, out comes 24. Okay? If I put 9 into this machine, out comes 9 times 4, which is 36. So what would I need to put into this machine to get a result of 44? So I can start at 44 and go backwards through this machine. And if I do, rather than timesing by 4, I'm actually undoing that. I'm dividing by 4. So I would need to put 11 into this machine to get 44, because 11 times 4 gives me 44, right? So I'm reversing the operations when I put a number the other way through the machine. So let's look at another machine that combines these two. So let's say I have a machine that times by 4 and adds 3, okay? So if I were to put, say, 8 into this machine, it'd times 8 by 4, 32, and then add 3, I'd get 35, okay? If I were to put 2 into this machine, times 2 by 4 is 8, plus 3 is 11. Now let's say that I ended up with the answer of 43. So what do I put into this machine to get 43? Now, when I have 43, I'm going to do the same thing and go the other way through the machine. Problem is that I will get different answers depending on which operation I reverse first. So if I do 43 and then divided by 4, I get 10.75. Then minus 3, you get 7.75. And that doesn't sound right to me. So it's important that I actually reverse the order of operations when I'm solving equations. So to figure out what I needed to put in this machine, I start at 43, but I do the last thing first. I undo the plus 3 first. So when I put 43 into this machine, I subtract the 3 to get 40 and then divide it by 4 to get 10. Now what you can do is you can think of this as 2 machines. So I can split these up into a times 4 and plus 3 machine. So if I ended up with 43, if I want to go the other way through, it seems to me to be a lot clearer that I need to subtract 3 first. So I start at 43, then I put it the opposite way through the plus 3 machine, so out would come 40. Just like up here, what I needed to do to go from here the other way through the machine was subtract 3. So 43 minus 3 gives me 40. Now instead of going the right way through the times 4 machine, we're going the opposite way. So instead of multiplying by 4, we're doing what we did here. To get from here to here, we divided by 4. So 40 divided by 4 gives us 10. And that's the answer, okay? Now, you may not seem like it, but we've actually just solved the equation. What is 4x plus 3 equals 43? What is x? We've solved that. X equals 10. Alright, so I'm going to show you exactly how I want you to solve it. So there's only two things you need to do. You just need to tell the story of what happened to x and then reverse the flowchart. So let's look at two similar examples of equations. So the first thing we're going to do to solve each of these equations is tell the story of what happened to x. So let's look at this one here. 2x minus 3 equals 36, okay? So you've just got to say what happened to x. So x, this wonderful guy, decided he was not big and strong enough, so he decided to get bigger. So he took some steroids and he doubled in size. Then one day while walking through a really dodgy area, probably something like Bankstown, where all the Bulldogs supporters are from, he got robbed and they took away 3 from him. And he ended up only 36. Okay? We want to figure out what he was before he went through all this stuff. So, we've just told the story of what happened to x, so that's first step done. Now we want to reverse the flowchart. So how we do that is we start at 36. Now, when we were going this direction, we subtracted 3. So when we're going the other direction, we add 3 because adding and subtracting undo each other. So instead of subtracting 3, I add 3. Now 36 plus 3 is just, that's right, 39. Easy as. Now when I come to this box here, instead of timesing by 2, so I times by 2 when I went this way, to go the other way I do the opposite. I divide by 2 to go through this machine. Now 39 divided by 2 is 19.5. Now you might be thinking, why did I give such a complicated example? Because I want you to understand that solution to equations, they can be negative numbers, they can be fractions. Okay, so the answer to this is x is 19.5. We can easily check that. So we substitute it into the equation. So 2x minus 3 becomes 2 times 19.5 minus 3. Now you can put that on your calculator and you'll see that you get the answer 36. Therefore we know we're right. So the answer to this is x equals 19.5. Please write your answer like this. Okay? Let's try the other one, which is only slightly different. So this guy, same name, he's X, but he just did things in a different order. So what happened to him was he was actually robbed first by the dodgy Bulldog supporters in Bankstown, and then he decided after that to take some steroids and double in size, and he ended up at the same place at 36, right? So if we want to figure out what X was to start with, it's almost the same process. So we start at 36. Now instead of timesing by 2, we divide by 2, and that gives us an answer of 18. Instead of subtracting 3, we add 3, and then we get 21. So the answer here is x equals 21. Okay? Again, we can check our solution easily. So 2, I'm going to take this exact equation. The only thing I'm going to do is change x to 21. Okay, and see if I get the right answer. So we do 21 minus 3 first, which is 18, times by 2 is 36. Okay, so we know our answer is correct. So these equations were very similar, but hopefully this highlights to you we get a totally different answer if we do the wrong order of operations. So you need to tell the story in the right direction. So if I was to tell a story about my amazing Year 7 class, let's say that I said, I met this amazing Year 7 class, then I moved to Marist. That you guys would think, okay, he's not talking about us, he's talking about a class from his previous school. But if I said, I moved to Marist, then I met a good Year 7 class, you'll know I'm talking about you, awesome kids, okay? So the order that you tell the story in is really important. You tell it in a different order, it is a totally different story. Just like for equations, if we write things in the wrong order, we get a totally different answer. All right, I'm going to do a few more examples. Okay, so let's try these ones here. So, again, these equations look very similar. The only difference is the order in which we do things. So let's look at this one first. Okay, so tell the story of what happened to K. So I took K. Now, because of BODMAS, I do the division before the subtraction. So I actually did K divided by 5. Then I subtracted 3. And I got 15. So to figure out the answer, I just do my second step. I reverse the order of operations. So 15, instead of subtracting 3, we add 3. Instead of dividing by 5, we times by 5. So 15 plus 3 gives me 18. Times by 5, I get 90. Again, we can easily check our solution, because if I substitute K for 90, I get 90 divided by 5 minus 3, and you can check on your calculator that that equals 15. Now if I do the other one, it is a bit annoying, but these K minus 3 is basically in brackets, because I do everything on top of the fraction first. So the only difference is here, instead of dividing by 5 first, I've actually subtracted the 3 first, then divided by 5 to get 15. Okay, so to solve the equation, start at 15. Instead of dividing by 5, I times by 5, and instead of subtracting 3, I add 3. So 15 times 5 is 75. You can use a calculator if you don't trust me. Plus 3, I get 78. So the answer to this, you need to write like this: K equals 78. Okay, so not sure whether you're right, just substitute K for 78. 78 minus 3 over 5, put it on your calculator, and you will see we indeed get 15. So if we substitute K for 78, we get a true statement. Therefore, the solution is K equals 78. All right, so only 2 steps. Draw the boxes, tell the story of what happened to X or K or A or whatever the pronumeral is, and then reverse the order of operations just like I've done here. Any questions, please ask. Other than that, this has been the luckiest maths teacher in the world. Have a great day.